Hi, Astronomy. Mr. Janowski here. This is the first video for the slides for Chapter 2, which is the rise of astronomy. So, kind of a broad history lesson, like a survey of all of the old astronomical ideas and the people who had them. So, quickly think back to all the things we learned about in Chapter 1: the apparent rising and setting of the moon, sun, and stars, the constellations, phases of the moon, solar eclipses, all of those things. So ancient civilizations studied these things and tried to explain how the heavens worked. They saw these things, they noted them, and they came up with their own ideas of how they worked. Some of their ideas were correct, others were just completely wrong. So that happens. So in bold, the question is, are all of our modern astronomical ideas correct? And the answer to that is going to be no. Of course, we don't know which ones are not correct. But throughout the history of science, yeah, you come up with ideas, you refine them, you make them better and better, and you think they're pretty good. But some new information always comes along, and you have to kind of refine what you were thinking before. So, uh, in science, yeah, you have to be humble. You can never be so arrogant to say, yeah, we figured this out, and it's done forever. So, yeah. And this picture, teach the controversy. Yeah, this is a joke. There's no controversy to teach here. This is showing a geocentric model with the Earth at the middle, the moon, planets, and the sun all going around the Earth. Yeah, that's not how it works. We'll get to that idea eventually. So, early ideas. Pythagoras, yes, that Pythagoras from math class, taught that the Earth was a sphere because he liked spheres. He thought spheres were the perfect shape, and so the gods must just have to have chosen spheres to be the shape of the Earth. And while it is true that the Earth is a sphere, uh, that's not a scientific reason for believing that. So we don't give Pythagoras credit for this idea. We do give credit to Aristotle because Aristotle was the first person to present evidence based arguments that the Earth was a sphere. Yeah, he had evidence for his ideas. So Plato on the left, Aristotle on the right. Here is the School of Athens. So, yeah, this is on one of the walls in one of the rooms of the Pope's apartments, the Stanze di Raffaello, the Raphael room, um, or the rooms. Um, so, yeah, School of Athens, great piece of, cultural heritage. Yeah, really good. Raphael, he sure could paint. So, yeah, quickly, philosophically, Plato gestures upwards. Plato's pointing up because Plato believed in the theory of forms. Plato believed that the world of perfect forms lies beyond our senses, so you have to trust your reason. So Plato thought, yeah, all the things you deal with, all the things you see and touch and interact with down here on Earth, these are just crude approximations of the true forms of things. Um, so you can't go by those. They're just imperfect copies of the real true things. So you have to trust your reason. Your reason can get you there. Aristotle believed in empiricism. Knowledge comes from sensory experience. So you have to trust your senses. So he would have known that your senses are not, you know, infallible, but they're the right place to start, according to Aristotle. And of the two, Aristotle is the one with the more scientific kind of idea here. Yeah, look at what you can see. Figure things out that way. Start with that. So again, Aristotle had two evidence based reasons for believing the Earth was a sphere. The first one is that during lunar eclipses, the shadow of the Earth on the moon is always part of a circle. And the only shape that always casts a circular shadow, no matter where the light is, no matter how the shape itself is oriented, is a sphere. So he said the shadow of the Earth on the moon is always part of a circle. So therefore, the Earth must be a sphere. Yeah, that works perfectly. Great. The other idea is this is something we talked about in the first chapter. Aristotle was aware that if you went very far north or very far south, you would see different stars because, as you're moving along this curved surface, your horizon changes. And so different stars become available to you and different stars become hidden. So he knew how this worked. And the ancient Greeks loved geometry. So he understood the geometry of this situation. And he said, yeah, if you go north or south, you see different stars. So that's proof that the Earth is a sphere. And it is. It's great evidence for the fact that the Earth is a sphere. Moving on to Eratosthenes. So Eratosthenes, way back in the 3rd century BC, calculated the circumference of the Earth, and he did it very, very accurately. And he got a little bit lucky that his calculation was so accurate, but good on him. He had a perfectly reasonable argument and understanding of what was happening here. So he thought the Earth was about 25,000 miles in circumference. So the circumference, again, of a circle is the distance around, or circumference of a sphere. Yeah, and he was only off by about 100 miles. So that's really, really accurate. 0.4% error. Amazingly accurate considering how long ago he did this and how crude the tools he had to use were. So he did this using geometry. So he knew that where he lived in Alexandria, he was head of the library at Alexandria. He knew that on the summer solstice, the sun was at its highest point in the sky in Alexandria, but it wasn't quite overhead. So the sun was still casting shadows, even at noon on the summer solstice. But he also knew that a little bit south of him, in a town called Syene, the sun was directly overhead on the solstices. And he knew that the sunlight shone straight down a well. So you could lean over a well, look down, and you could see the reflection of the sun because it was literally directly overhead. So he used this information and some geometry to determine the size of the Earth. So the exact argument you don't really need to know. Just know that it was Eratosthenes who did this, and he did it using shadows and some geometry. But basically, if you remember back from the geometry you learned in our math department, alternate interior angles, a little bit of this, a little bit of that. And he figured out, this interior angle from the center of the Earth to Alexandria and from the center of the Earth to Syene. And he measured this angle, pretty tough to actually measure this very accurately, but he knew that it was about 7 degrees, so about 1/50th of a circle. He knew the distance from Alexandria south to Syene was about 500 miles. So if 500 miles is 1/50th of a circle, well, that whole circle, or sphere, must be 50 times 500, 25,000 miles. So yeah, his argument works perfectly. Good on him. And then we watched this video about why there are still flat earthers. And there still are. And the reason is basically because some people are stupid, is the reason. There's really no forgiving them at this point. We've known this for more than 2,000 years, that the Earth is round. We even know how big the Earth was. And serious thinkers really haven't doubted that fact in that long. And so the people who still believe it, they believe it because they want to be special. They want to be different. They want to think that they're in on a secret. Everyone else is being fooled, but they figured it out. That is a very appealing way to think for some people, but of course it leads them horribly, horribly astray. And these people are, there's no nice way to put it, they're stupid. They're worthy of derision. You would be right to have no respect for the flat earthers. They're just literally that dumb. So, yeah. Not to be too much of a misanthrope or too cynical or too negative. But yeah, some people are stupid. You can write them off. So to review, who had the first evidence-based arguments that the Earth was round? Well, Pythagoras said the Earth was round, but those weren't, he didn't have an evidence-based argument. The first person with evidence for his arguments? Aristotle. The shadow of the Earth on the moon during a lunar eclipse is always circular. And if you go north or south, you will see different stars. Great. Both of those arguments work perfectly. And who was it that used an obelisk, which is like a tall needle-like monument, an obelisk in Alexandria, a well in Syene, and some geometry to calculate the circumference of the Earth over 2,300 years ago? Eratosthenes did that, and he happened to luck out. There was lots of errors in the measurements he made. He didn't get the angle exactly right. He didn't get the distance from Alexandria to Syene exactly right, but he lucked out in that his errors happened to cancel each other out very nicely. Doesn't always happen, but it worked for him. So yeah, good on you, Eratosthenes. And that's it for part 1. So hopefully you found that helpful.